Hello, my dear students. Class number 8. Each time at the beginning of class pronouncing the number in order it's more convenient for you and for me both to understand where we are. What is the subject of today's class? Engines innovation, as you might see. But actually, we are going to talk not even about engines. We are going to talk about much more wider idea about power plant of aircraft and about the propulsion system of aircraft. But first I should say that in previous video, in previous lecture, what is like full-scale class, normal video, at the moment of recording at the end, I have encountered internet problem. And at the end, you see some unfinished piece because it wasn't recorded what I was talking there about. Well, practically everything at the video, everything what is important, and video is usually, do forgive me, longer than necessary. Even being cut, it's longer than necessary. We need to come back to matters of structures, aircraft structures next in practical classes. So we will talk about. But before I start with aircraft engines, I will remind you one important thing once again. Not even about aircraft structures, what they look like, and so on. About the formula of Zhukovsky again, not again, would say you. Yes, again, look, I have already even wrote it instead of open it in Telegram. And please do pay attention. We also need to recollect the scheme of forces acting to the airplane in horizontal flight. And I hope you do remember, in order to continue horizontal flight, the lift force equal to the gravity force, to the weight. And do imagine the situation that we have two airplanes of the same weight. But one is a speedy airplane, no, let it be business airplane or some passenger airplane. And another one is flying bicycle, let's say, agricultural airplane, which has very low speed, just because such airplane don't need high speed. But do imagine we have two equal airplanes by weight. By weight, they are equal. It means that lift it's the same, should be each time. And what does it mean for us? If lift is the same, what do you imagine? One airplane, the bicycle with wing, flying with a speed 50 kilometers per hour. And another one, no, it's not business jet, it's too slow for business jet. It's some medium passenger airplane, medium speed. Subsonic, of course, and not much fast, as you might see, because it's approximately 0.5 of Mach number in kilometers, if we take it in kilometers. Well, one is flying with the speed 50 kilometers per hour, and another with speed 500 kilometers per hour. Do pay attention to formula. In formula, and we need to have equal lift. In formula, let's imagine that this one and this one, not quite clear, this one, it's quite equal from both of sides, in both of cases. And how to have balance, considering that we have these two components, multiplication of two components, as you might see, squared speed and area of the wing. Do imagine that area of the wing here equal to the 1. It just values which does not correspond to reality at all. It's comes only about to see the difference, to see proportions, to understand what it resulted in. Look, here we have speed 500 and area of the wing equal to 1. 1 square meter, 1 square kilometer doesn't matter right now. Next, what is next? How to have balance. Here, some unknown value, and don't forget its square should be here. So, what it's really equal to? If we consider here a square, I took such values on purpose, as I said you, in order it became much obvious. 25 two zeros, to unknown value, and here we have 25 and 4 zeros multiplied to unknown value. Takes me more time to draw these values than to pronounce it. And now, to understand what this equal to, look. And what do you see? It means that in order to have here appropriate force of lift, the area of wing should be 100 times more than in this case. No, once again, it doesn't come about any realistic values. It just to remind you how significant the flight speed for outer, not even shapes, but for outer sizes of airplane in this case. And the more low speed resulted in greater sizes of airplane itself. But now let's recollect about such effect. Force is equal, but in one case we have huge area and here we have very little area of the wing. But force is equal, the same value of force. And now let's distribute this force as a pressure to the surface. And what do we have? Little forces distributed all over the surface. In case of low speed, tiny forces. And sometimes, or some dozens of times, greater forces that act to each elementary area of the airplane surface. In this case, if we have less size of the airplane faster, size of the airplane wing is less, and quite clear that this it's called specific load. Yesterday I used this. Yesterday in previous class I used this term, this concept. Specific load to the structure is much more higher than in case of low speed aircraft. That is why structure of aircraft may be very different, and depending on in the most general to say, depending on these specific loads to the structure may be either of truss type or beam type, and in turn beam type also may be of longeron type or spar type, depending whether it's fuselage or wing, of so-called torsion box type or semi-monocoque type, like it comes when it comes about the airframe of the fuselage. And one more possible structure in case of the wing, stabilizer, flap, and so on, such a structure is called integral structure or monolithic structure. It's not really monolithic, it's just type of structure. And in case of the fuselage, it's called monocoque, like one shell, one egg. But in contrary, like their names are similar and ideas are similar, seems like. But in real, look, the spar-like structure, so-called sparse structure of the wing and longeron structure of the fuselage by names. They are similar, but they are not really for quite the same structural loads. In contrary, what really like they are with similar names, but it doesn't mean that they are with similar working with similar specific loads. No, all those matter in details. You should have you should study in design disciplines. It's usually the subjects of third year, fourth year of studying. Maybe it's too early for you right now, but I trust that you already not first years really. I'm talking to you as to first years, but time to time, I'm trying to stand on your real knowledge, which must correspond already maybe to the third year, as far as I understand. Okay, let's stop this yet, and let's come back to the immediate subject of our conversation. Right now, you see three pictures, and these three pictures are the most popular aircraft engine by now, the most popular aircraft engine types by now. But we will start from far distance once again, and first I'll open you some definitions in order we use the same terminology, all of us. And the very first, maybe I should open not even this, but somewhere here I have prepared. Look, the full version, as I said you. Thanks to you, I have found so many books in this subject. Some years ago, when I last time have a need to find some additional books for my students. No, no, do forgive me, not for me, but for students. And when I've been searching for these books in internet, then it's maybe not all of these books been in open access by that moment, and I forgot to check sound. Maybe I'm talking to myself. Do forgive me. Uh, Certainly not. Sound is recording, and what I forgot to check. I forgot to check time. Moreover, I need to write down the time. I did it. And now in free access, it's a lot of different literature, and even I have found Federal Aviation Administration portal with free open manuals, books, and so on. And all these widely illustrated, beautiful books, they're actually of FAA books. And maybe that pilot book that I shown you and gave you before, it's some like short version from FAA books of previous years. No, the final one that they propose is of 23rd year. You will have it also. And additionally, I have copied some chapters of no, it's not given like the whole book, and it's given by chapters about aircraft power plant, about another matters. Do forgive me that I do not copy everything, just because it's rather complicated, I would say, to copy everything that I don't need. For you, I think it's enough to have this chapter about aircraft engines and this chapter about propellers. And actually, it's even too much. No, for first years, it's even too much. But I prefer you have all this literature. I prefer you have these sources of information. Maybe they will be useful for you, or at least interesting somehow. Well, once again, aircraft power plant. Aircraft power plant is wider idea, wider concept than just an engine. Aircraft power plant we understand as system of engines and some systems which deal with engine. For instance, oiling system, system of engine control system of engine, maybe some pneumatic system, hydraulic system, which is somehow related to the engine. Plus to this, usually we have anti-ice system, and in most of airplanes and most of modern airplanes, anti-icing system against icing of the airplane in flight. It's also related to the engine, because some surfaces, they are like warmed up from inside by the air taken from, no, hot air taken from engine exhausts, and so on. So aircraft power plant, it's much more wider idea than just engines. We are mostly talking about engines, of course, with you. But I need you to understand that it comes about engines and some systems which working for engine, like fueling system, oiling system, cooling system, and so on. Control system of the engine itself, and the engines and the systems which depends on engine. Usually it comes about conditioning system in no, especially in passenger aircraft, and usually it comes about the anti-icing system in passenger and cargo aircraft. Here you see in this book it's explained that aircraft engine or power plant, they do something like no, they use like sign of equalacy between power plant and aircraft engine. It's not quite the same. And moreover, modern airplanes, you have seen dozens of airplanes, and you understand that modern airplanes, they usually have some engines in their power plant. Some engines, no, because what that is the question actually. Why we use some engines? No, when it comes about passenger or cargo airplane, it's maybe also because of safety rules. Even ICAO restrictions, ICAO airworthiness and so on documents, they demand to have compulsory no less than two engines, and in case of a long range flight over the water, like between continents, it should be not less than four. In case of failure of one of or even two engines, airplane may continue the flight on two last engines. And engines divided, like, no, the power plant divided onto three or four engines seems like it help you to provide reliability in terms that you duplicate your twinning or tripling your thrust generators, and in case of failure of foiling breakage of one of them, you may continue the flight and may land then. And it's one consideration. Another consideration, maybe you have very big airplane, and in this case you just have no engines of proper force, of proper thrust, which able to provide the all necessary thrust for your airplane, not only cruise flight but also takeoff. Takeoff need much more thrust. Most of airplanes that we are talking about, they have in cruise flight, maybe they use engine time for half only, and no, for half of their possible thrust. But during takeoff and during landing also, they need to use all the thrust, so call it maximum thrust. And no, one more consideration, as I already said, maybe you have no engines, the only engine which is able to give you all necessary thrust. One more consideration, the third group of consideration, sizes of engine. Sizes of engines, they, if you do imagine that, okay, there is some engine which exists with necessary thrust, but size of this engine may be much more. For instance, you have a speedy airplane, no, supersonic, and this supersonic airplane is not big in sizes, no, some medium airplane, or in even some little airplane. But for providing the flight and for takeoff, you need huge thrust. And due to this, it appears that engine will be greater than airplane itself. And also it's not appropriate. And in this case, may help that you use couple of engines, but this couple of engines, they approximately correspond to the sizes of airplane. However weird it sound by now to you. Well, let's start again with definitions, as I said. In understanding of aircraft engines, no, first, as I already said you, all designers, they have crazy idea fix about minimum of mass providing, and all technologies, they have idea fix about classification, categorizing of everything, to find prototypes and to find some analog to our future activity, let's say. Like to understand all the features, to understand all the characteristic of object, and you already understand what to do to this object. So after some short explanation, we will go into classification of engines above the all. Sorry for taking the same picture for so long. Like just to entertain you, will try to show you if I didn't lose it. Maybe I'm already lose it. Oh, what? Look at this. After you've been entertained with this picture, let's come back to explanation. Sorry, it's like to soften my words to you. Так, let's come back to explanation. As I said, propulsion system and propulsion. Propulsion at all, what we understand as propulsion. When we're talking about power plant is aircraft propulsion system to produce thrust. Propulsion, you see, it's is understood no? As generation the force. Generation the force, and to pay attention, any combination, either it's pushing or pulling. So propulsion is a process of generating the force to provide some translational motion of the object. And in this, no, you see it comes from Latin words also. Practically, it's like forward and drive. Forward motion, to drive forward. And one more important moment, it's called propellant or propellant. What is it? Some working mass which either expelled from engine. Oh, we don't know where from. uh, Either expelled or expanded in such a way as to create the thrust or some another motive force. And look at this working mass, reaction mass. No? What is propellant? Mass against which system operates in order to produce acceleration. So what is propellant? It's some piece of matter, let's say some volume of matter that is used to produce acceleration by the way of either expelling or expanding in sizes, in volume, in order to create thrust. And I need you to understand and remember. No, this in so-called powered aircraft or powered flights, you do remember that we talking about 4 principles of flight: ballistic, aerostatic. Next we have rocket flight, and next we have aerodynamical flight. And only 2 of them, rocket dynamical and aerodynamical, they are so-called powered flight, powered aircraft, because only rockets and aerodynamical vehicles, they have engines. So propulsive force in powered aircraft may be obtained by displacement of air. And it's not compulsory atmospheric air, as I wrote here, because when we come into discussion of rocket flight in vacuum, it will be not atmospheric air. So it's maybe my not mistake, but I should change this, please. And no, as it's said here, air is not necessarily the same that used inside the engine. But what I need you to remember, that thrust can be developed only by 2 ways. There are no another ways of this. Propellant is an air, you understand, and question is how to move this air, how to use this air, how displace this air in such a way that uh, it's resulted in appearing of opposite directed force, thrust. Either we use prop motion or we use jet stream. Prop motion help us, like to expel the air from itself and like it drop it behind itself, and uh, this dropped air push us front, push aircraft front. Each motion of prop it's resulted in taking no, like it's screwing in inside the air. No, it's maybe wrong comparison. No, I hope it help us to understand. Like it's swim inside the air and drop the portions of air behind of it, and due to this, it's accelerate airplane in opposite direction. And one more another way is jet stream, and it's also practically the same story. But first, how it's a pure jet stream. You expand some air, you add fuel and expand air. Uh, air compressed air will have more higher pressure and speed in this case, and also it's expelled from engine in opposite direction, opposite to the flight direction, and due to this, according to the third law of Newton, we goes front forward. Well, do remember that either prop or jet stream. There are no another options. And when we're talking about human-powered flight, uh, steam-powered flight, electric-powered flight, or any another type of power for flight, either we have prop or engine give you jet stream. Well, and let's continue now with slides. I hope it will be a little bit less boring now. And we will go to classifications. And in this classification, to forgive me, I will draw again. No, not draw, but do some notes in front of you. Very well. Engines. Look at this. Time to time, I will use. No, really, there are screenshots actually, even from the appropriate. Course of Delphi University. It's somewhere in Netherlands. 10 years ago, something like this, about 10 years ago, I took their videos in open streaming portal. But after this, they mostly hide those videos. But the videos of real lectures been in free access, and some photos from these lectures I use in my slides. But look at this. Here is you see the lecturer in class, and slides here show no those anecdotes of different types. Later, maybe later we will see together some of those funny pictures which are called the dreams of different groups of designers, or dreams of different people as to the airplane. Those who busy no, how people would like airplane looks like, what aerodynamic group, designer group, manufacturer group, strength group, those who are responsible for weapon, for instance, and so on. Those who are responsible for propulsion system for power plant, of course, they would like airplane to look like this. And the funniest fact, he said that such airplane really exist. No, you see, practically the whole airplane, it exists from engine. Yeah? A very insufficient wing, the less sufficient stabilizer even, and it doesn't look like airplane. It looks like a barrel actually, and this barrel has a couple of wing and stabilizer, and due to this, it may also fly. And what he proposed as classification. No, look at this. The big groups four big groups here: human powered, electrical engine, air breathing engine, and rocket engine. One type of heating machine it's missed here. However funny is it, but no, I said you already about our engineer Majayski of 19th century, who have considered making the first flight. It's already maybe a closet. No, great. Steam engine, steam driven airplane, steam powered, steam powered airplane, and his airplane. It was approximately here, 82nd, and his airplane was on steam engine. Oh, does not exist. Photo of his airplane does not exist. Oh my. Oh, oi. Okay. Yep. Here is. But his airplane, as I said, you in our country, it's considered like first powered flight. But as I said, you at the first, his flight has finished with crash, so it was not successful in modern understanding. Wright brothers were the first who made first successful flight, and his airplane was really the first airplane that looks like modern airplane. By the word about flying bicycles, look at this. You do remember what did I said, that in case airplane speed is low, wing will be huge, and that is the real, no, that is the RC model of Majayski airplane. After almost 80 years of his flight, it was proven that this airplane, they just repeated his airplane but in scaled model, and stuffed it with electrical engine, and his airplane was normally able to fly. But look at this airplane, and what do you see right now? It's very similar to steam machine, to steam machine, to steam train. Yes, you see what it looks like. It has pipes, smokes, and so on. Something very unusual because it was steam engine flight. But no, this one it's unsuccessful. As we remember, this flight was unsuccessful flight, and so steam engines they are like not really usable for the flight. Wait a second. I have closed it occasionally. Those matters, those pages that I have opened for you with illustrations. Wait a second. Steam engine. Steam engine airplane. Not clearly remember how that page called. What steam powered aircraft? Yeah. I just opened it a second ago. I forgot already. Now, and what was surprise for me when preparing to your classes, I didn't remember really about this fact, but steam driven airplane existed and been even in used for some years. It's not one flight this airplane made. It's a called Basel Brothers airplane, which was really steam engine. No, it was real steam engine, like machine that work on the water, steam, on the hot water practically. And the advantages of this machine were, among the others, that it was practically noisy. It was not noisy and not harmful. No, of course it was harmful anyway, because how they got steam, um, they should burn some another fuel uh, that to heat up the water, to make water, to make hot water and to make water boil in this heat machine. So anyway, it's again comes about carbonizing of our universe, but whatsoever these drives existed. So let's try to start our classification of engines. Again, nothing visible. Let's do another. Let's stop making me crazy, my dear computer. Please don't shame me in front of students. Так. Ты посмотри. Сумасшедший. Чумачечий компьютер. Aircraft engines. Maybe I have very big page here. That is why not everything normally visible. Aircraft engines on maybe divided into some big groups. And to start with elementary thing. No, first we have human-powered flight. Aircraft engines, maybe it's better to call to give some another name here. No, I hope you understand what it comes about. Human-powered. What does it mean, human-powered? Really, we will see. Human-powered flight. Powered. I don't like. Next, steam engines, as I said, and try to show you what was for me at beginning like a sort of anecdote. Steam engines. At the end of 19th century, of course, people been using the steam engines because they have no other types of engine. And with appearing of inner combustion engine only, it's became possible to make flight. Why? No, because steam engine actually it's too heavy. We maybe not quite understand what does it mean too heavy, but do recollect what I've been saying about the principle of mass minimum, and engine should be light enough, providing this thrust, in order to move itself and machine which engine placed it in. And in case engine provide insufficient thrust with respect to its own weight, it's called non-effective in this meaning. It's non-effective in terms of weight of engine. This ratio of thrust given by engine to the weight of engine, it should be as big as possible in order this engine may be used for providing the flight. But steam engines, they are considered like non-efficient in this meaning. They are too heavy with respect to the thrust they produce. Next, no, look, Next, in history, next was group of uh, air breathing engines. But right now, let's leave here the place for electrical engines, which are in fashion now. And let's continue. Electric engines. And let's continue with next group. Next group of engines is inner combustion engines. How to see everything temporarily, at least. Inner combustion engines, and these inner combustion engines, they are actually in a big group. But let's draw a line here first, and this line we will call air breathing engines. Air breathing engines. And inside of this group will be one more important classification. And besides of air breathing, which correspond to the air permanently during air work, what really they are breathing with air. And by their names, it's already understandable. They may work only in atmospheric air. In case no air, in case of vacuum, they are not able to work at all. And there are another type of engines. They are not used in airplanes. Usually, they may be used in airplanes, like additional engines uh, for accelerating during takeoff, for instance. But of course, they are not used in cargo airplanes and passenger airplanes. Mostly those type of engines, they are used in rockets, really. Especially in space rockets and ballistic rockets, but it's just the name of such an engine. It's called rocket engine. It may be used in airplane, I said you, like auxiliary engine for takeoff, for instance. Rocket engines. They do not need permanent correspondence to the air, permanent communication to the environment, because they use oxidizer which already on board. So rocket engines usually, no, they are of closed type combustion chamber, and usually they consist practically of combustion chamber plus special no, exhaust channel, let's say, so-called nozzle of Laval nozzle. And rocket engine it's has no intake holes for air sucking inside. And now in air breathing engines, that will be a little bit complicated now, but I do this classification in front of you, like the whole classification, on purpose, in order you have the whole picture of this story. And time to time we will come back to this picture in order to see where we are. Now, air breathing engines. The first in history has appeared piston engines. In this history of air breathing, actually rocket engines, they have appeared even earlier than air breathing piston engines. They have appeared already in the middle of 19th century, and of course in experimental devices, in experimental vehicles, and they are early in history than air breathing engines. But if we consider this classification, what else I do behind of appearing time of appearing in history? It's like the line along which these engines increase their capabilities. Let's say like this. the far along this line, the more capable engine is. No, it's also not quite correct, because more capable, it doesn't mean that it's able to everything. It doesn't mean it's better. It means that it has properties with higher speed, for instance, thrust, and so on. But as only you increase in thrust, engine increase in thrust, it means that you are limited in something else, or you have disadvantage in something else. No, like everything in our world, everything has balance. Okay, once again, piston engines, or another name, reciprocating engines. Look at this. Reciprocating engines. I do not like this word. It's difficult for me even to pronounce this word. Reciprocating engines, and I used Chinese here on purpose. In order, you might see what it looks like. There are two names for this group of engines, and that is more scientific like, and the most common, of course, is, as I'm already said you, piston engines. Why pistons? Because of their design. Piston engines. Piston engine. Oi, 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 oi. Where you are? Piston engines. Maybe I will not. I will. But clever woman already may copy down this word half an hour ago. Piston engines. Piston engines and piston engines also may be divided in some different types of engines. Actually, when it goes into this classification, we will go far. Next, jet engines. Next big group is jet engines. And this big group, actually, I should write these jet engines. Maybe I'm wrong. I should write jet engines already here. But again, it's not compulsory, not completely correct, would be. So these are also maybe considered like jet engines, but not all the engines out of this group are considered like jet engines. Do forgive me. So let's call the next group. Oi, oi, oi. Let's call the next group turbo engines. Turbojet engines. Turbo engines or turbojet engines. Turbojet. And these turbojets, they are not the only in air-breathing engines, because we have turboless engines, but they are not called like this. In English, they are called RAM engine and scram engine. In our languages, Slavonic languages, they are called they have the same name. In English, they distinguish RAM and scram engine depending on their inner shapes and depending on speeds they give. I should say at once that those engines, they are for hypersonic speeds. Let's type the name and let's leave this place yet. RAM, its abbreviation. RAM and scram engines. Oi, it's okay. RAM and scram engines. Now turbojets. Turbojets, it's also a group of engines which started with well-known turbo. No, I shouldn't call them turbojets. Actually, do forgive me. I should call them turbo engines. My mistake. Sorry. Turbo engines. Да что ж ты меня сегодня мучаешь? Ну что это такое? Turbo engines and ну что? How it's put the What does it mean, turbo engines? It means that they have turbine. You understand? Turbine inside or turbine-like devices inside. Turbo engines, they start with so-called turboprop engine. Why I removed this word turbojet engine? No, above the all, it comes about really clean turbojet engine. In English, it has such a name. And the first in this group of turbo engines, turbo gas even engines, they are called turbo gas engines. They are turboprops engines. Let's type. People, it's something today. Like computer trying to work against of me. Turbo, no, of course not. Turboprops. Turboprops, similar to them. Turbo shafts, which are actually quite the same practically engine as turboprop, but prop is not in front of engine. Prop is shaft is going out the engine from backside, and the shaft is joined to the prop on backside, and it's with special reducer and reductor. No, this reducer is to rotate the shaft for 90 degrees, to rotate the direction of movement. And due to this engine may be used for helicopters. Turbo shaft engines here, turbo shafts. Very similar to turboprop, turbo shaft. Don't mix up with turboprop. Turboprop may have prop propeller in front of engine and behind of engine. In one case, it's called pulling scheme. In other case, it's called tractor scheme. It's just the same. No, it's like way exhaust is directed to, seems like. In aircraft photos, we might see it. But really, like beginning of engine seems like, no? Usually with the prop, but in some of those engines, you will see the prop on backside, and it's still the same turboprop. And turbo shaft, it's exactly engine for helicopters. It's a little bit different in design on the backside of the engine. And additionally, it has powerful, massive reducer, which responsible to rotate the shaft to 90 degree in another direction. Next, we have turbo jets, exactly. Turbo jets. Turbojets. Next, we have turbofan engine. Once again, it's with changing of their capabilities. We are turbofans, turbofan engine. Next, we have turbojet with additional combustion chamber with afterburner. Let's give place for these afterburners. Turbojet engine with afterburner. It's like the same practically turbojet, but more powerful in case you switch on this afterburner chamber. Maybe used, maybe not used. And one more group which appeared not so far in time, да? I've seen it already with some different names. It may be called prop fun, it may be called open fun, and some other names I met. No, let's write here prop fun engine, and next we will see it's in photo, and I hope next you may recognize it in different under the different names. In particular, I seen a name unducted fun, like this engine with unducted fun. No, I say you, English language, it's a problem of terminology always, because until they agree how to call it and other things in dozen of different countries that use English language. Так, once again, prop fun. Prop fun, or as I said, you may meet it under the different names, depending on company who going to develop it or who provides this engine, and so on. And of course, each company who give another name insists that they use some another principle, for instance, in engine. Really not. Так. And once again, come back to all the picture. Engines are the sort of machines. No, in case of this one, this machine, it's not machine, yes. And engines either join it with the prop, and prop is responsible to accelerate air in backward direction, or engines, no, they are like spitting the air, compressed air backward again in order to push aircraft in their forward direction. And all these engines, by source of energy responsible to either rotate a shaft with the prop or for creating the jet stream, they may be divided into big groups. And these big groups, they are, no, you see, human-powered engines. It means that someone rotate the shaft, like in bicycle, and the shaft is joined to the prop. And due to this, airplane will have thrust. Next, steam engines, the most ancient one and practically not being in use. No, besides this bustle biplane, which was used during 2 or 3 years. It was in operating, the group of these airplanes, it was in operating. It's operated by post offices of USA. Electric engines, which are very popular now, but their capacity is not significant yet to provide the flight. And do forgive me again, however people talk about their sustainability, about their safety of these engines for environment, in order to get electricity, in order to get electrical energy, anyway, we are burning some resources in order to have this electrical energy. Well, there are, of course, exclusions, like we use the water energy, like hydropower plants or atomic energy, and due to this, we have some accumulation of electrical energy for using it on those engines. But you understand, I hope, that by now it's like not serious. These engines can't be in wide use. And additionally, we have, not we, but at all, there are serious questions to those accumulators' safety at all, because even in phones, such accumulators, they are not safe enough when it's just a phone in your pocket. And do imagine something like this might happen, like overheating and explosion somewhere in flight. And electric engines, of course, they used in the same way like piston engines, like steam engines. They just join it to some prop, to the shaft. They rotate shaft, and shaft is finished or started or finished with the prop. So they are all these engines, including piston engines, they are completely create thrust. Like if I outline it, this group of engines, what is our propellant is an air, but what this air moves, pro, pro propulsor or something like this it's called. And here we have 100% of thrust by prop. What about the of those engines? No, green. What air breathing engines? Rocket engine, ram scred engine, afterburners. Maybe we need to exclude this prop fan. Afterburners and turbojets. Actually, turbofans are easier because they have no open prop. No? Fan is hidden in, no, it's like ducted in special channel. It looks like huge probe with a lot of blades, but it's hidden inside the cooling of the engine itself. And here we have around 100 of thrust already by jet stream. And when it comes about turboprop and turboshaft, it's combination. Look, I was said I can't find it somewhere else, especially in English literature. No, maybe I was unattentive and not searching for good enough, let's say. But I do remember, and it's given in our literature, that around 30% in these engines, thrust of these engines, is given by the jet exhaust in turboprops, and around 70% it's by prop. When it comes about turboshaft engine, their exhaust really it's like exhaust practically, and it's practically does not used for providing the flight. And in this case, either 100, depending on the engine design, either 100 by prop or around 90% of thrust created by prop. Not less than 90%, only due to the rotation of prop. No, main rotor of the airplane, you understand, it doesn't come about the prop in this case. Practically it's the same prop but directed vertically, and whole this thrust practically it's appearing due to rotation of the main rotor of turboshaft engine, and rotation of the main rotor resulted in rotation of main shaft rotates the main rotor of the helicopter, and when helicopter fly, it's deviate a bit from vertical axis, and due to this resulting force of main rotor, it's decomposed onto lift force and to the pushing force, like this force of thrust directed forward with respect to the flight. And due to this, such engine responsible for creating the shaft. Forgive me, the thrust. But really, the turboshaft engine is responsible also for creating the lift directly, practically, as you might understand. Now let's start watching the engine inner arrangement, let's say, for different engines. I will try to be as plain as possible and as short as possible, but first thing I should said before we goes on to pictures of engine, why at all we need to study this and to understand this. We are not engine engineers. Yes, we are engineers which work with structures of airplane, with general structures, glider structure, as it may be called, but not with engines. It's not our task to create engines. Yes, but our task is to select engine. When you're designing airplane, your task is select the engine. One of your subtasks is to select the engine. And how to select engine? No, above the all, of course, we are talking about the necessary thrust. We need thrust, and due to this, we understand we need that or another engine. Okay, let's go to the market and see the whole variety of engines looks like this. Which one? No idea. And that is why we need to look inside of the engines to understand their advantages, disadvantages, and above all, we need to understand the field of their operating, because each of such engines it has limitations which depends on their design. No, for discipline which is called introduction to the major, it would be quite enough to understand the basic differences between them. And we are going to talk about these basic differences. And next, we need to understand also as I said you already, ranges of their application, let's say. Let's start. Where is our program with slides? Once again, no, let's compare what we did. Very little. With slides that you have already seen. Propeller propulsion and jet propulsion. And propeller propulsion may be, no? As we may have seen already, it's maybe powered by human, it's maybe steam engine, electrical engine, piston engine, and even turbojet, turbo engines, turbo gas engines. I should have written here turbo gas engine in order to understand better. And these turbo gas engines, they are hidden in, you see, the no, turboprops engines and turboshaft engines. They are hidden inside of turbo gas engines. And similar thing made the lecturer in that university. You see, red color is related to the jet propulsion, and you see how he explained it. No, maybe he need to change here color to the red here, maybe. Да? Rocket engines, they are jet propulsion, and air breathing engines, as he gave here, they belong to one group and to another group. So either it's probe responsible for creating this thrust, or it's jet stream which is responsible for creating this thrust, or their combination. Let's see air breathing engines. Once again, remind you, we have also such a level, air breathing engines. Some things you already know, piston engines, and next we have turbo gas engines, which represented first by turboprop, turboshaft, turbojet, turbofan. Maybe I need really place it in such an order, but okay. And next group of air breathing engines, there are ram and scram engines. And no, in our understanding, it's the same engine. In English, they use two different names, two different modes, two different ranges of speed of such engines, depending on their inner shapes of this diffusor, confusor, and other matters. Why you do not reduce? It's decided that it's already too little, maybe. No, this program is not reducible properly. Very well. And here you see the slide with explanation of operating of this reciprocating engine. I can't remember, can't study this word by heart already maybe for 30 years, and practically I have no hope to pronounce it properly. Reciprocating engine, reciprocating motion should be at all said. And how does it work? What it looks like, I have found, thanks to those who developed them, I have found bright slides here. Aircraft engine. Oh, here is piston engines. And this I thought I have more. Okay. Well, piston engine here, it's represented in a picture. You see, I've seen somewhere the mm, animation of this, and wait, так, attention, guys. Sorry, I thought I have prepared everything. Maybe no, the internal combustion engine or piston engine. Oh, oh my. Ah, here is. Да. And that one was also opened separately but disappeared. Maybe I closed it. Uh, right now we see animation. It's maybe not so boring for you as slides, as your new generation children. And look at this. What it consists of, this engine. We see one element, one piece of this engine, one combustion chamber. Actually, this engine completely consists of combustion chamber, but it has some communication to the air. On one hand, it has intake channel, as you might see in this picture. It's on the right, intake channel, and that one is so-called intake valve, uh, which is responsible to close and open the duct for intaking the air, for sucking in the air. As only you intake the air, uh, here is the special ignition device, which sparkling time to time. Is it possible to stop it? No, seems like not. It's possible only to continue with it. And this intaking air mixed with the fuel, special device, another device creates a mixture of air with fuel. Uh, this mixture of fuel air mixture combusted, it's ignited with sparks of this ignition device, and as a result, after burning the air quite clear, it's very hot temperature, and it's changed in the volume. Changing of volume of this air resulted in the reciprocating of piston, of engine piston. This device, engine piston, it's resulted in the motion down of this piston, and the piston itself, by additional device, is joined to the so-called crankshaft. So you see this device move up down permanently, and due to the this hinged rotation, it's possible forgive me, due to this hinged joint, it's possible to rotate the shaft. And next, at the end of the shaft, do imagine that you have finally you have the prop, and prop is making our thrust, like taking the air and dropping back the air opposite to flight direction. It seems like very simple. The equation is only is it enough to have one combustion chamber or not? No, certainly it's not, and that is why usually those engines that we see the only combustion chamber, like this, да? The only, but it's not the whole engine. The whole engine normally consists of some such combustion chambers. Вот. You see the piston is inside of one of combustion chambers. The rod and crankshaft. Crankshaft show us already animation. And you see these combustion chambers by blue. Pistons rotate shaft, and here we have prop. Great. What is interesting for us? No, you understand maybe that they may be different by cycles. There are two-stroke engines, four-stroke engines. Moreover, there are another types of cycle at all. Usually we use these gasoline engines, as they are called, and maybe of two-stroke, maybe of four-stroke. Four strokes are more effective and like more powerful. What is given in slides here is quite the same that we have seen in animation, actually. And it's explained like intake, compression, no, intake, next, ignition, actually. Next, expanding the air in the chamber, motion the piston down. Next, in contrary, opening the exhaust valve here on another side, and due to what you say, no, here slides are with mirroring, let's say, because usually intake is shown on the left and usually, yeah, and exhaust is given on the right, and in that animation it was like mirror, and you see intake, and here you see already exhaust. No, finally, everything is happened, let's say, in one cycle. It's one cycle, but this one cycle it's repeated uh, sometimes, no, sometimes per minute, quite clear. And there is no one such combustion chamber, but there are some of them. Typical positioning, typical placing of these um, combustion chambers for different engines, we see it right now. No, maybe you get used to see it in automobiles. Maybe you've seen it in automobiles. Maybe you have automobile at all, and you may see it immediately. They are mostly used to call it linear engines. Linear engines that may be aligned along one line, or in aircraft, more usable were those accommodation like V type piston engine, you see, like literal V for placing the combustion chambers with inner pistons. It was necessary to create aircraft with compact sizes above the all. And one more variant of placing of such combustion chambers of these little tiny engines, sub engines, let's say, inside of the same engine, it was radial positioning of them along the central axis. Whatsoever both of cases, they are finished up here with prop, and prop create the thrust. Well, and next group of engines, what this no, here it's called propeller propulsion, да, what piston engines, they're here. Next group of engines, they also use prop. They look like this. But do pay attention how distinguishable, let's say, the appearance of this engine. Engine is here. Pay attention. Here is the engine, and here is the engine of piston type. And what should I say? That really, what here is its engine with prop. Here, this prop is not so big. Normally, the proportion of prop diameter for this engine, prop diameter is much greater than diameter of engine itself. So engine is comparatively little, but these prop blades, their lenses, it's approximately, no, for modern airplane, they would be approximately each blade with length of each blade approximately like height of human. Do you imagine those sizes? What is inside of such an engine? Let's go to the book. Book, help us please to see the pictures. Actually, we have these pictures in another slides. I've prepared it, but anyway, I would like to use my slides to show you, and anyway, I would use something to draw. while explanation, because what do you see right now? You see two different types of engines. You see the difference? Do forgive me. Like gas turbine engine, basic turbojet engine looks very similar. There is a difference, but we not notice it. And here is one more type of engine, so called turbofan engine. Do you see the difference? No, it seems like it's fast, fatter. No, it's wider, this engine. Yes, because really the engine itself. What do compare this picture, for instance, and this picture? Engine itself, it's hidden inside. Here is the engine that we have seen previously, but this engine, it's like surrounded with additional cooling here, and in front of this engine we have additional, it's called fan, turbofan, but in contrary to, look at the turbofan, no, in contrary to what I did. I know what I did. In contrary to this engine, it has much more blades at all. It has more amount of blades here, but these blades, they are much less in diameter. No, the length of each blade is much less, but anyway, they are huge also, especially for big airplanes. No, whatsoever, this fan size is more compact than prop size for engine of the same thrust. I'm not talking about another differences right now that they not usable, let's say, in the same area of speeds and attitudes. They have different fields of application just because of prop limitation. Z1 may be used in more speedy airplanes. Z1 may be used only in, like in approximately up to 0.7, 0.8 Mach number. And next, the size of prop is too great on one hand. And on second, the loads on prop will be too significant, and moreover, the downwashing of prop itself it will be not subsonic, and in this case, prop became not effective. No, in the simplest words to explain it, look at the engine that is called turbofan. What here is turbofan engine. Actually, it was one of the first turbofan engines, and these two young ladies, they are stewards from one of the first flights of Boeing 747, if I'm not mistaken, where I took this photo, like historical photo. And to compare, as I said, size of engine to human height, you see that girls are staying inside of this place, and approximately here is human height. But engine of prop type, in this case turboprop engine, it will have even of greater size. Engine itself will be not so big, but prop will have much more significant diameter with respect to the if it's for the same thrust. But once again, say you, just like remind you that in this case, this engine barely able to stand the same, to provide the same speed as turbofan engine, because really prop is a limit in this case, the prop itself. Now here we have seen the same engine, and here we see turbofan engine. It's Airbus A380 engine. And examples of those engines, that is also turbofan, that is open fan or unducted fan or prop fan. It's considered like hybrid of turbofan and prop engine. You see here the like logotype, the slogan or whatsoever, how it's called, symbol of NASA. I have prepared for you, not prepared, but I have found a video occasionally and copied it. And this video right now, not this one I can't copy to my PT. The video that next I will download you in case you have time. You will watch it. Additionally, this turboprop what looks like this. On no, do not touch it in order to. Okay, no, something like this. And in this case, it's directed. You see, like tractor scheme with props opposite the or props in front of the engine, and in some cases it's directed backward. Well, and watching the time with one eye, and I understand that I was too slow again in explanation. So instead of showing you some pictures of engines, let's try to explain you in the most simple way what happened inside the engine and their peculiarities and their fields of operation we need to discuss after some short break in order to have different classes. And do take a look onto this slide. That is maybe the best explanation ever I've seen about turbo gas engines at all. It's a scheme, primitive scheme of so-called continuous combustion in turbo gas engine. Intaking the air, what here is engine. Along the engine, we have devices which are responsible for. Let's use here the picture of engines, if possible. Now, let's place. Ай, не хулигань. And that one. So you see, along the engine, we have device for intaking the air. It's like sucking air inside. Next, it's compression of air. There are devices here which are called compressor. They are called compressor. Next, you have combustion chamber. And after combustion chamber, we have exhaust. And exhaust is in channel of special shape, as you might see. And due to this, air being exhausted, it has much higher velocity and higher pressure. And it's like really like expelling with very high speed from engine. And due to this, this expelled air push us front. What I said, the best explanation ever. Look at this. Suck, squeeze, bang, blow. What really sucking the engine, squeezing, air is squeezing through the engine. Да? Bang, it comes about the combustion chamber. Really, it looks like explosion. And next, it's blowing out the engine, like spitting out the engine with very high speed. I missed one element in this scheme. This one, rock. And one more important question. It's great. How it's by the word, how it's intake, how it's compressed. Compressor is a sort of also it's a sort of prop with dozens of it's more complex than just prop because it has prop which rotates and it has additional blades which are between the lines of this compressor, between the discs of compressor, and all this creates a complex aerodynamical channel and some ducts, let's say, to provide the compression of the air as much as possible. The higher compression, the better capacity of engine will be. And once again, compressor rotates. The shaft should rotate. Compressor rotates, and due to this, it's sucking the air inside, like it's create additional. It's give additional force to suck air through the engine. And no, you understand that here we have higher pressure, so air would not like to go inside voluntary, let's say, by its will. Yes, it's necessary to suck it with force. For this, we also have here the special intake ducts, intake channels, intake shapes of those channels appropriate for sucking the air. Exactly. Next, ignition of this air with mixture of fuel. Fuel is supplied here through the special nozzles, fuel nozzles, and this mixture of high compressed air with fuel ignited, no, because it's already actually once been ignited at the beginning of engine work, in contrary to the piston engine where ignition each time should be done for each cycle separately. Here it's like continuous cycle. It's continue to burn permanently here in the combustion chamber. But once again, to continue to support this burning, it's necessary to suck the air permanently. And question is how to make compressor to rotate. After engine been started, no idea how it was started. No, let's imagine it's already work, but how make it not to stop? And here, on the way of engine, hot engine, which like willing to expel from the to escape from your engine in order to expand at last, to have normal parameters. On the way, you have one more additional device, and this device name is turbine. That is why those engines, they are called gas turbine engine. This gas turbine engine has always inside devices like compressor and turbine, and combination of what is turbine in contrary to the compressor, which take take air outside, suck air from outside to inner section. Turbine it has another direction of blades, and what it resulted for. No, if we consider the each particular cross section of the of this one and that one, of compressor and turbine. Turbine, it's like stealing the energy of this combusted air, and in contrary to compressor, it's rotate the shaft, and this shaft is with compressor. So turbine seems like unnecessary device, because passing the turbine, air lost around 10-15% of energy that been developed in combustion chamber. But in case no turbine, no rotation of shaft. No rotation of shaft, no rotation of compressor, no intake at all, no sucking the air inside the engine in this case. And the primary task, the very first task, is how to start this shaft to rotate, because at the beginning, quite clear, until air inside the engine with velocity and pressure like outside in atmosphere, turbine can't work. Yes, turbine need compressed air to pass through and start rotate the turbine, and turbine rotate the shaft, join it to compressor. No, actually it's the same mechanical, it's the same device. They are on the same shaft. And how to make it rotate for the first breath? Usually we have additional auxiliary devices to make this engine work. And what I was saying about aircraft power plant, that aircraft power plant consists of some engines, and some of them may be even of another type. They are so-called auxiliary engines, auxiliary power plant, or auxiliary engines. And usually when it comes about the passenger or cargo airplane, usually they are hidden somewhere in the aft fuselage, in the rear portion of the fuselage. We not see them at all, because they are either of piston type, or of electric type. And these auxiliary engines, they are necessary to start up, yeah, to start motion of the shaft. Motion of the shaft will be resulted in compressing of air here through the compressor on the way. And as only compressor start work, it's resulted in combustion of air in the combustion chamber, burning in combustion chamber, and next air it's already able to rotate the turbine, and somehow it became like eternal engine in this case, yes, until it's continuous burning here. It's continue to rotate the turbine, and turbine is continue to rotate compressor and sucking the air. Of course, it's not eternal engine, as you understand, because first it needs some first kick. What I should add also to story about auxiliary engines that necessary to start the gas turbine engine, that it's maybe either on board engine like in big airplanes, or in case of no, for instance some little airplanes, it's maybe also something like engine or accumulator or some another device like this on the airfield immediately. No, some starter device which is responsible to start turbine to rotate. Uh, Once again, how this engine work, it's continue rotate and continue work, actually continue the burning and expelling the air due to rotating of the turbine itself. This hot air responsible to rotate the turbine, and turbine which is stealing energy of no, like useful energy of this engine, is extremely necessary, because no turbine rotation, no compressor rotation, no compressor rotation, no more portions, new portions of the air to support to continue burning inside the combustion chamber. No, I hope you understand somehow this dreadful story about sucking, squeezing, banging, and blowing, and details about the differences in these engines. Maybe it's after short break. Right now, let's stop.